This section is on polygons. You'll have to memorize the chart on the left that says number of sides and the name of the polygon. You need to know all of those polygons. If I asked you to classify a polygon or name it, you would have to use that chart. You also need to know the vocab words side, vertex, and diagonal. And so the diagonals, since they're two non-consecutive vertices, then I could go from one vertex. I cannot go to either neighboring vertex, so let me get a pointer out. So I can't go from this blue point over to the red, because those are consecutive. And I can't go from that blue point to the red, because those are consecutive. But you can go across the way, so I could go from that vertex to the other, or I could go from this vertex to that one across there. So those are diagonals, vertex to vertex, as long as they're not neighboring vertices. Regular polygon is an important word as well. A regular polygon states that we have equal angles and sides, or congruent angles, congruent sides. So the best way to know these definitions of concave and convex, they're talking about diagonals, and I can explain that better in person if you want, but concave is a shape that caves in, and convex does not cave in. It's the easiest way. So sum of interior angle theorem says that the sum of the interior angles of a polygon, the S, is equal to n, which stands for number of sides, minus 2 times 180. So for instance, if we have a triangle, we would have 3 sides. So S equals 3 minus 2, this is for a triangle, times 180. These are for regular polygons. That needs to be stressed somewhere.
What's the 2 then? Wait,
I lied. It's not really for regular polygons until I do each interior angle, so scratch that thought for a minute. Yes. So if we simplify this, 3 minus 2 is 1 times 180. So the sum of the interior angles of a triangle add to 180 degrees, which we already knew. But this helps us for all other polygons. If you have a regular polygon, you can find each angle by taking the number of degrees in the triangle, so the sum, and divide by n, the number of sides. So for instance, in a regular triangle, it would be 180 degrees divided by 3, this is for a triangle, which would tell us that each angle in an equilateral or equiangular triangle is going to be 60 degrees. Again, we already knew that, but this is where these ideas come from. These theorems are proving this. All exterior angles of any shape add to 360 degrees. No matter what shape it is, all of its exterior angles add to 360. If you're trying to find each exterior angle of a regular polygon, you'll take 360 and divide by n. So for this figure, we could solve for x by adding our 2 exterior angles. We have a triangle here. It's 3 sides, so it's going to be, well, it doesn't matter how many sides, I'm sorry. It's all going to add to 360. Any shape adds to 360 degrees. So we add our 2 that we have so far, we subtract from 360, and we would get 81 degrees. X is 81 degrees.